Today we're going to do an exercise on transformation geometry. As you can see from our book, here's our question. It is a fish in the shape of a square and a triangle. We're going to use a translation, axial symmetry and central symmetry in this orientation on our page. So for this we're going to draw it around this position. For our translation will be over here, down here. Axial symmetry will be in this position of our page, and then finally central symmetry will be up here. So just make sure to get a proper layout of your page correct first, and try and keep it in the middle of our page. That's the most important. So the first thing we must do is draw our rectangle, which goes around our fish. So we basically it's a rectangle 50 by 40. Just draw in our, and then from the question we have it in a grid format. These are 10 mil in dimension and 10 mil up the vertical line also. Making sure our T-square is in flat against our board, and put our set square against the T-square and draw our vertical lines. And then we can simply, obviously making sure again that it's square and sitting tidily against our board, you can bring your horizontal lines across. From our question, point A is here. Since it's a square, all sides are the same length. So we can use our 45-degree set square to quickly draw it. For the end of our tail, is basically a triangle shape. Like so. Now we have our point. Point A, our translation from our question, A to A1 is 100 millimeters. So get our set square again and measure down 100 millimeters. And now we've point A1. A translation from our video is when all our points move downwards and translate the same length, same distance. So we simply do the exact same as what we've done. You do not have to bring down the grid, as we already have our grid drawn, like so. And there's our translation, is when from A1 to A to A, from A to A1, the same distance applies for everything. So as you can see, 10, 10, 10, and 10. 10 centimeters or 100 millimeters. Next part of our question is going to be axial symmetry. Obviously the key part of that is our line of symmetry. So the main dimension here is 140 in total, split in half, 70 and 70. So we get point Q, 70 mil in. So we move along here, bring our line across. The total dimension here is 140, so we get A2 here. But the most crucial part is our line of symmetry. And that's how we get axial symmetry, is when we have a line. So I'm going to use a darker pen to show this. Obviously bringing it past the 2 points up on either shape, so we can label it P, Q. So from here to here is 70, and from here to here is 70. For axial symmetry to take place, bring all our lines, all our points to our line of symmetry. Then, getting our compass, we can mark here, like so, marking all our points, moving it out to the point, the respectable point. That's that point there, correct. Point on our tail, there. And finally this point here. Here. One point that some people miss out on is this point in here, where we can form the rest of our triangle. And then we simply continue our lines, and where they cross over our line marked by the compass is where we get our shape. So we can simply, like so, like that. And that is how axial symmetry. The main difference between axial symmetry and a translation. Translation is when our object just moves down in a direction. Axial symmetry is when our shape moves through the line of symmetry but flips and faces backwards. So it flips over. As you can see, it flipped. From our question, A3 for central symmetry takes place up here. So A2 to A3 is 100 millimeters, as we've discussed here. But to get central symmetry, we must have a center point, which is point Z. So that's the center of 100 millimeters. So 50 up, we get point Z, and then 50 on another bit, we get point A3. So simply, first come up our 100 mil, bring across. Now we have A3. Half of 100 is 50. Here's our point Z. For central symmetry to take place, A2 is going through Z to get A3. We must put all our points through point Z. And that is central symmetry. It's an important part that all points go through point Z. Make sure you have enough room finally this point here. And then we can use our compass. So we'll start out here, we'll mark this. There's that point. Just to show to you, A2 and A3 are the same. This point down here. It's an important part that we all pay attention to this part. And finally, we have that one. We have to get this one. Have we this one? We do. Have we this point? So we have all our points. So then basically what we do is join this to this. Like so. And now our tail. And then finally. And there is central symmetry. Remembering that a translation is the basic movement in a certain direction by the same length. So A1, A to A1 is 100 millimeters or 10 centimeters. So all these points must go the same distance. For axial symmetry, comes to the line of symmetry, we get our compass and we swing our arcs over all our points. We bring our lines, continue them over horizontally, and where the compass marks